Hello, today we're going to look at one of the most important sources of energy in the world today, which is crude oil. We're going to look in this video at how we can separate crude oil into its useful components, what those components can be used for, and some of the properties of those components. So what is crude oil? So crude oil really is, and the simple definition is, it's a mixture of hydrocarbons. So a mixture meaning two things that are not chemically bonded. And a hydrocarbon, I'll just give you the definition for a hydrocarbon again. A hydrocarbon, remember, is a compound containing only hydrogen and carbon atoms. So crude oil is a thick, gloopy substance containing all sorts of lengths of hydrocarbons. So a real mixture of hydrocarbons. So now we know what crude oil is, we need to think about how we can separate the different components of crude oil into actual useful things that we can use in the real world. And to give you an example of a component or fraction that we need to get from crude oil, one of those is petrol, which is the fuel that many cars run on. So remember, crude oil is a mixture of different hydrocarbons, and because there are lots of these different hydrocarbons, they have different length chains, and therefore they have different boiling points. And it's the difference in boiling points which is the key to being able to separate them. So we're going to use a process called fractional distillation. And I'm going to go through this in a way which means you get the main points for the exam and the marks that you might need in any exam question. So we'll go through the different points, talk about each one. First thing you need to do is you need to heat the crude oil. And that's done in a furnace. So it's heated until most of the crude oil is vaporized. And then it passes into this column, which is called a fractionating column. And you do actually need to know the name of the column. Now the fractionating column has a temperature gradient in that it's hotter at the bottom and it's cooler at the top. These are all exam specific points. So the shorter hydrocarbons will have lower boiling points and they will rise up through the column until they get to a temperature that's below their boiling point. And therefore they will condense at a point that is nearer the top of the column than the bottom. So shorter hydrocarbons have lower boiling points and they rise to the top. And then the last point that you can add on here is that different fractions condense at different points depending on their boiling points. So now we've looked at how we separate crude oil, and these are the key exam points. It comes up quite frequently. We're then going to look at what the different fractions are and what they can be used for. So this page gives you a better picture of the fractionating column and the different fractions that come off in crude oil. And we've got them there from top to bottom. These are all the ones that you need for the iGCSE Edexcel specification. So going from the top to the bottom, you need to know the order of these, and you also need to know what they're used for. So there's quite a lot of information on this page. Key points are names of the fractions and what their use is. So at the very top, we have refinery gases. And refinery gas is the sort of thing that you will use in your homes for cooking or for heating in most gas boilers in homes. And if you think in a lab, the Bunsen burners run off refinery gases. Next one is much more familiar to you all, is gasoline, or more commonly called petrol, and that's used as a fuel for cars. Next one down, and we're getting longer, so the hydrocarbon chain is getting longer as we go down the column. Kerosene, and it's used as a fuel for aeroplanes. You don't need to know specifics of boiling points, you just need to know names and uses and where they sit in the column. The next one is diesel, and diesel is used for trucks and trains. I know it can be used as a fuel for cars, but in the specification they usually say fuel for trucks and lorries. The next one, even longer hydrocarbon, is called fuel oil, and that's for fuel for large ships or for power stations. And the longest chain hydrocarbons are right at the bottom, and these tend not to actually ever turn into a gas. They stay as a liquid the whole time in the process. It's called bitumen, and that's used for road surfacing and roofing. So the last thing we're going to think about with the fractional distillation of crude oil is the trends of the different fractions in the fractionating column. And we're going to look at three in particular. We're going to look at boiling points, we're going to look at the colour, and we're going to look at the viscosity of the different fractions. So the first one to think about is the boiling points, and just remember that as you go up the column, the hydrocarbon chain gets shorter, and as you go down the bottom of the column, you have the longer hydrocarbon chains. And that means when we think about boiling point trends, the ones at the top of the fractionating column have lower boiling points. They're lower because there are shorter hydrocarbons at the top, and then at the bottom they have the highest boiling points. So the trend is it goes from low to high as you go down the column. So low boiling points at the top, high boiling points at the bottom. So you might be asked to pick between two fractions in the middle, for instance, petrol and kerosene. Now petrol is further up the column and therefore has a lower boiling point than kerosene. The next one is the colour. And you just need to know the trends. You need to know at the top, they tend to be lighter, so they're probably more likely to be colourless. And then as you go down the column and as they get longer, the hydrocarbon chain, they get darker. So it's lighter to darker. So you might have to make an observation about which one is likely to be higher up the column based on its colour. Last thing is viscosity. Viscosity is technically what we'd say is resistance to flow, but more simply, it's thickness. So a low viscosity means something is quite runny, and a higher viscosity means something is a little bit thicker and doesn't run as easily. A really easy example to that is think about honey and water. Honey is much more viscous than water. And if you think about the trends in the column, the shorter chain hydrocarbons at the top of the column have a low viscosity, and the longer hydrocarbon chains at the bottom have a higher viscosity. And a really simple explanation is longer chains are more likely to get tangled up in themselves and therefore not flow quite as easily. So those are the main trends. So that's boiling points, colour and viscosity. And you will also come across others, things like flammability, how easily they are to set fire to. The shorter chain hydrocarbons at the top are much more flammable than the ones at the bottom. So refinery gases, you can ignite them and burn them much more easily. They're also more volatile, and volatile means they turn into a gas much more readily. So those are a few other trends that you might come across. So we've done boiling point, viscosity and colour, and there are things like flammability and volatility as well. But that's pretty much everything you need to understand for a fractional distillation of crude oil.